Good evening, geometry students. Tonight we're doing Module 3, Topic 4, Writing Proofs. This topic uses standard GR 1.1, prove relationships and theorems about lines and angles, solve mathematical and real-world problems involving postulates, relationships, and theorems of lines and angles. The objective, you guys will analyze and construct viable arguments. And the essential question for this topic, what makes a logical argument? And how are logical arguments used in geometry? Start with the bell ringer. Pause right here. Work the bell ringer, and then we'll check back together after you do your part. Sorry, got a little distracted. So, bell ringer. The point R lies on line segment PS. So, draw line segment PS, and they tell us R lies on that. Doesn't say, in the middle. It just says it lies there. We're going to put it somewhere in between. So, where PR, try to get a different color here, is 5x, and RS is 6x plus 1, and PS, so from P to S, so the whole thing is 56 units. What will be the value of x? Okay, so you can see I've got 5x for my PR, RS is 6x plus 1, and the whole thing is 56. So as we've been doing a little bit every day, we have a whole line, and then we have two pieces that are going to equal the whole. So the whole line is 56. It's going to be PR plus RS. And then I'm going to substitute those. PR is 5x, RS is 6x plus 1. I have a 5x and a 6x. I'm going to bring this over here. 5 plus 6x is 11x plus 1. So now we're going to subtract 1 from both sides. 11x equals 55. Divide both sides by 11. And x is going to be equal to 5. So just another line segment problem. Alright, guided notes. We're on page 1 of week 6 packet. Module 3, topic 4. Excuse me, my paper would scoot. Let me write in our words here. Sorry, I don't have my red pen. I left all of them on my desk in the classroom. I usually have more. I tried to make that a little more legible, and I made it worse. Alright, so recall that Euclidean geometry is based on logical reasoning. A proof is a logical argument in which each statement is supported by a statement that is accepted as true. These supporting statements can include undefined terms, definitions, postulates, and theorems. A two-column proof is a proof that contains statements and reasons that are organized in a two-column format. You can develop a deductive argument, sorry for the sloppiness, deductive argument to prove a statement by building a logical chain of statements and reasons. Key concept. This is important. How to write a two-column proof. Step 1, list the given information. And if you've been in class at all the last couple of weeks, I've said more times than I can count, 97% of the time, the first statement in a proof is going to be the given information. And right here, step 1, list the given information. and draw a diagram if needed. Most of our proofs are going to have the diagram, but there will be instances you may need to draw it out. Step 2, create a deductive argument that links the given information to the statement that you are proving. I'll do all this in the example to the right here momentarily. Let's continue. Step 3, justify each statement with a reason. Reasons include definitions, postulates, theorems, and algebraic properties. And then step 4, state what it is that you have proven. So over here in our example, complete a 2-column proof. Our given is that Q is the midpoint of PR. Q, right here, the midpoint. Okay. And they want us to prove that PQ is congruent to QR. Okay. So statements are on the left, reasons on the right. Number 1, Q is the midpoint of PR. The reason is that is given. As I said, 97% of the time. Number 2, PQ is equal to QR. And that is true because if Q is the midpoint, then this side would be equal to that side, and that's the definition of a midpoint. And then lastly, number 3, and that's what they're asking us to prove, is that line segment PQ is congruent to line segment QR. Notice here they're equal to one another, and then down here we're saying they are congruent. And that is the definition of congruence. We've talked about in class several times equals and congruence. Congruent means equals. Equals is for numbers and congruence is for shapes. So when we're talking about lengths, we're talking about a distance or a number. When we're talking about a line segment, we're talking about this geometric figure, this line. So we go from equals to congruent, and that's the definition of congruence. I'd say probably 90% of the proofs we're going to do in this class, we're going to have something like this, where we go from equals to congruent, or we go from congruent to equal. Notice it's PQ and QR, line segment PQ, line segment QR. We're talking about the same things. We're just talking about a number here and a shape here. But either way, these two things mean equals and congruent mean the same thing. So when you see this, it's going to be the definition of congruence. Or I think in an example in another topic we do, they say congruent segments are congruent or equal or whatever. But either way, you'll see a lot of equals to congruence or back and forward, but it's always going to be the definition of congruence when we do this. I'm making a big deal about it because it is a big deal. Okay, off my soapbox. Okay, bottom of page 1. It says number 3. I don't know where number 1 and number 2 went, so this is the first one anyway. We're going to create a 2-column proof. Our given is that xy is equal to 11.3 centimeters, and that yz is equal to 3.8. We have a word bank here, and most of the times you guys will have a word bank that we can choose from that makes this a little easier. Alright, so here's our statements. They want the reasons, and we're going to use the word bank. So first statement here says xy equals 11.3 and yx equals 3.8. Well, that was our given up here. So let's check that. And given. Hopefully you said it before I did. Alright, next statement says xy plus yz, so xy plus yz equals xz. So this piece of the string or line plus this piece equals the whole thing. Now it says betweenness of points here, and I wish that they had used a different example, because we're going to talk about in the next module, the next topic, that about line the segment addition postulate, and that's what this is. But for this particular example, remember that between every point there are infinite amounts of points, so this would be betweenness of points. Okay, third statement. 11.3 plus 3.8 equals xz. So we have simplify or substitution. Well, we substituted xy they told us was 11.3. So we substituted. So this was a substitution. And then finally we added them together. We got xz equals 15.1. That was what we wanted to prove, but we simplified or we added like terms. Our examples are going to show quite a few different. It'll say simplify, it'll say solve. It'll be a little different to begin with, but it'll finally settle on whatever the reason is at the end. And it'll usually, because we'll be dealing with shapes, it's going to be some sort of rule or postulate. But for now, because we're simplifying numbers to get used to writing proofs, we're going to have the last reason is going to be a little different in some of these examples. All right, number 4 is a you do. Please pause the video here. I'm going to wait about 3 seconds, and then I'm going to work this problem. I'm asking you to pause, work the problem, and then let's see how you did. All right, number 4. Create a 2-column proof. Given mn is 4.2, so they gave us that, and they give us that ln, the whole line, is 8.7. They want us to prove that lm here is equal to 4.5. So here we have the reasons already listed, and we need the statements. So the first reason says given. Our given was mn equals 4.2 and ln equals 8.7, so that's right here. Okay. The next one's filled in on both sides, betweenness of points, and it's mn minus ln equals lm. I would have written that ln equals, lm equals ln minus mn, but it's fine. We know what we're saying. We're subtracting this from the total to get this. So that's the betweenness of points, how far it is between here to here. And then, so next it's substitution. So notice here we have 4.2 and 8.7. Like I said, this is written backwards, and you can't have negative links, so that's why this bothers me, but I digress. We substituted mn and ln for the numbers, the letters for the numbers, so substitution. And then lastly, simplify, or what they wanted us to prove is that lm is equal to 4.5. When you subtract 4.2 from 8.7, you get 4.5. Okay, let's flip over to page 2. Let's get the center up here. All right, page 2. A flow proof, or a flow chart proof, uses boxes and arrows to show the logical progression of an argument. The statement is in the box and the reason is below it. Arrows indicate the order of the steps. So here's our first example. Let's get this away so you can see a little better. Write a flow proof to prove that x is equal to 2. Our given is that P is the midpoint of JK. So before I even look over here, I'm going to try to get you guys to do something that may help. So it tells me that P is the midpoint, and if P is the midpoint, then I already know that JP is going to be congruent to KP. So I'm just going to mark that before I go over there, and this is going to help me along the way. They want me to prove that x is equal to 2. They give me also that x is the distance, but that's the measurement for JP, and then 5x minus 8 is the measurement here. So as we look over here, we see that our given was our first statement. It's P is the midpoint of JK. Then they tell us, oh, look at this. JP is congruent to PK. JP is congruent to PK. I've already marked that. And why? It's because P is the midpoint, and if it's the midpoint, those two are congruent. So there's my theorem, there's my reason. I already gave myself number 2 before we even got there, because of just knowing ahead of time and keep getting our brains to think, okay, if it says bisect or if it says midpoint, we're talking about 2 equal pieces. So these 2 are equal pieces, they're equal or they're congruent. So I'm going to mark them before I even start the problem. All right, now we're going, so this was statement 2. Statement 3, JP is equal to PK. Segment JP is congruent to segment PK. JP is equal to PK, the definition of congruence. I said probably 90% of the proofs we do in this class, we're going to have one of these going one way or the other, sometimes more than one in these proofs. So I want you guys to look for that. So next we go, x is equal to 5x minus 8. So x is equal to 5x minus 8. We substituted JP for PK, and PK substitution. Excuse me. All right, so notice here, x equals 5x minus 8. They subtracted 5x from both sides. So that's subtraction. If you didn't have that, you could look down here and notice that you went from x and 5x to negative 4, and you could tell that it subtracted out. But these are things we'll learn along the way. Anyway, we subtract 5x from both sides. We get negative 4x is equal to negative 8. And the substitution here is we substituted x minus 5x for negative 4. So we subtracted to get this, but to get from there to here, we substituted. You could also say simplify because we combine like terms, but in this case they won't substitute. All right, next we divide both sides by negative 4. That's division. And then we get x is equal to 2, and that it says substitution here, and this is where I get aggravated because it said simplify over there. It says solve, I think, on the next page. It also said prove in some places, but either way, this is what they wanted us to prove. We did substitute negative 8 over negative 4 for 2, but still. Alright, this is a we do. So since there is no we here, it's just me, I'm going to do this, but I'm going to kind of pause in between, and I hope you're paying attention. You know, if you're really trying to learn this, I hope you're following along, and hopefully you get to where you can answer before me. I know a lot of you guys don't answer in class because you're afraid you're going to be wrong and somebody's going to give you a hard time. We don't care. You guys don't need to worry about that. Everybody's trying to learn. Everybody's at the same place, and if you just happen to get one wrong, who cares? Most everybody else probably would have guessed wrong too. So anyway. So write each statement and reason in the correct box to complete the flow proof. So our given is that FG is equal to HK. So these two are equal to each other. What's another word for equal that we use in geometry? Congruent. So they're congruent. I'm going to go ahead and mark that. I know I'm doing a flow proof. Probably going to come up. So first statement here was FG is equal to HK. Given. The next one is a substitution, and there maybe should be a word bank, but that's okay. We're gonna do this together. So if we're substituting here, FG was 4x minus 6 equals HK, 22. All right, so then we go down here, and I'm going to just tell you that, so we got 4x minus 6. We're going to add 6 to both sides, so plus 6, and then 22 plus 6. And this is addition property, because we're adding 6 here to get rid of this, and then to get x by itself. So you come up here, and you got 4x is equal to 28. So we substituted 22 plus 6 for 28. Next we're going to divide. So division property. 4x equals 28, divide both sides by 4. You're going to have x left on one side. 28 divided by 4 is 7. And I'm just going to say we simplified because I can. Okay, down below this, we got a few more guided notes here. Alright, another way to prove a conjecture is to write a paragraph that explains why the conjecture for the given situation is true. This is called a paragraph proof. A paragraph proof includes the undefined terms, theorems, definitions, or postulates that support each statement. Just maneuver the camera down here to the bottom. I'm just going to do this whole thing because it's the paragraph part, and here's the word bank, so it's not really a I do, you do, and besides, it's just me here anyway. So, number 8. Given that y is the midpoint of xz and that xy is congruent to wy, write a paragraph proof to show that wy is congruent to yz. So obviously we're talking about these over here. Now, let's look at what they've given us before we even look at the word bank and look at the paragraph. So they told us that y is the midpoint of xz. So I know that xy and yz or zy are congruent because it's a midpoint. Alright, and they also told me that xy and wy are congruent. So this is going to get a little wonky, but we're going to have, because these two are congruent, and then this guy is congruent to this guy. So it looks a little strange. Just this is telling us that these two are congruent. This is telling us that these two are congruent. Okay, just marking things out. Okay, so over here to our paragraph. Because y is the midpoint of xz, xy is congruent to yz by the midpoint theorem. I said if you get in the habit of at least marking these congruent, that's basically how I taught myself geometry. And I'm hoping you guys are going to pick it up the same way. Okay, so next statement says, by the definition of congruence, so if xy is congruent to wy, then xy is also equal to wy by the definition of congruence. And xy is also equal to yz. That's xy and yz and xy and wy. I think no, that's right. Okay. By the symmetric property, now we actually picked this up. We talked about it earlier in Module 1. We're going to talk about it in the next topic. It's, if A plus B equals C, and if A plus C equals B, then C plus B equals A. Anyway, I'll go into it more later, but by the symmetric property of equality, xy is equal to wy and can be written as wy is equal to xy. And by the transitive property, so we've got xy is equal to wy is equal to xy, wy is also equal to yz, and by the definition of congruence, wy is also congruent to yz. So we took a minute to get there, and I hope that you understand this. If not, let me know in class. I may have to throw another video at you guys or some other resources just to try to help. Proofs are a big part of geometry, so if you are stuck, seriously let me know so we can get you right going forward. Alright, so this is the end of topic 4. The independent practice for this particular topic is in McGraw-Hill. If you guys go into McGraw-Hill, that's the, not Alex. Alex says Alex. It also has the little pie chart. I'm talking about McGraw-Hill. It has the picture of the pier out on the beach. Click on that. You'll see independent practice for Module 3, Topic 4. I think there's 4 problems, and those are due by before we take the test. But that concludes this topic. If you got any questions, let me know in class. You guys have a good night.